So hello everyone. This is a technical walkthrough call of the Shardeum core boost. Yeah, I'm gonna stress this out. We're covering core boost functionality during this technical walkthrough call. We're gonna cover ancillaries boost in just 2 days on July 11th, same time, same place. But for now, we're joined by one and only Shardeum team, Mehdi and Tim. They will both present the Shardeum functionalities. From Immunefi side, it's me as always, Tim, and also we're joined by our technical person, Gleb, who will also help us with keeping up the conversation. That being said, some final words here. Shardeum core and ancillaries boost are already live. You can check them out on our website, immunefi.com/explore/boosts. You can just go there, check out the 500,000 bounty for 500,000 reward pool, apologies, for the core boost and 200,000 reward pool for the ancillaries boost. But enough of this. Let's dive straight into this. Mehdi, Tim, please take it away. And thank you for being with us.
Yeah, thanks, Timothy. So my name is Mehdi. I'm a lead security engineer with Shardeum. I'm joined by Tim, who's a senior security engineer at Shardeum. And Devendra is here too. He's brand spanking new, and he's going to help as much as he can. So a couple of things I want to emphasize before I get to the code is that Shardeum is a large code base. We were talking to Immunefi, and I think it's the largest that they've worked with. Is that true? Or it's up there at least. So we're splitting into two boosts.
It's definitely up there. Yeah.
It's up. We're splitting into two boosts. The boost we're talking about today is the Web3 centered code. And there's two components to this. The first, let me share my screen real quick. Make sure screen one, it's all prepared. Everything on here can be shared. Okay, y'all can see it okay? Yep, okay. All right, so the base layer is the Shardeum core protocol, which is the main decentralized layer one protocol that's, if you're into Web3, you're probably pretty familiar with at this point, although we do have some quirks. And then the second part of this is Shardeum itself, which is the DApp on top of it. And Shardeum controls the user transactions and whatnot. The base protocol controls the network itself and handles consensus. So let me see real quick. My notes. Where'd my notes go? Okay. So let's talk a little bit about Shardeum and what the network might look like. So this is from our internal monitor server. The graphic itself doesn't really matter, but the idea here is this is what a small network would look like. The green circles in here are active nodes. They're part of the actual network. They're consenting, processing transactions, monitoring their performance loads to vote on whether the network needs to increase or decrease in size. And then the gray nodes out here are in standby. They're nodes that are not actively processing, but they're in the list, they're in the queue to join the network at some point. Sorry, I said queue, it's not a queue, it's random. So it's currently set to 60 seconds, but this is a parameter that can be adjusted. The network rotates. So some of the active nodes that are processing will become inactive and either join the standby list or leave the network completely. Some of the nodes in the standby list will rotate in, sync their data, and start consenting and processing transactions. An important and unique aspect of the Shardeum and Shardeum network is sharding, its namesake. The idea here is that we don't want the entire network processing every single transaction. We've noted that that's a bottleneck in some other networks. That's it's only as fast as its slowest or least powerful node processing. So we want to split up transactions across subsets of nodes in the network so that not every node has to process every transaction. And this is key to how we achieve the linear scalability, more performance, more TPS for every node that gets added to the network. And this is also where a lot of the tricks and probably some of the security flaws might come in that you all might find. Is in the sharding logic, because it hasn't really been successfully completed and pushed to production in any other network so far, and we're treading new ground. We have a lot of new novel ideas here, so we expect there to be a lot of payable bugs, in our sharding logic, in our rotation logic, because we shard transactions, we shard state as well. So there's a lot of unique and novel ideas here that are ripe for vulnerabilities and ripe for payouts. What else do we have here? So standby active, rotation, sharding, consensus. Okay, so our consensus algorithm here is what we call proof of quorum. And big picture, it's basically majority rules. So if when a transaction comes in, or whether it be a user transaction or a network transaction, the nodes in a specific shard will vote on it. And I believe that the current cutoff is 66% of nodes vote positively for it. It passes. If less than that vote for a transaction, then it fails, and the user would have to resubmit it. There are some quirks and uniqueness to that, but I'm sure you'll find that in the code, and there are more write-ups on that public on the internet. So one thing that we've found from previous engagements with auditors is some confusion around the role of archive servers. Archive servers are not a part of this boost. They're part of the ancillary boost. And we probably would have included archivers in this boost initially, if not for the previous audit findings. But we found that there's some confusion because the archivers are not key to our consensus or security of the protocol. The archivers just hold historical data, and they archive historical data. That's it. The network doesn't need archivers to run. So we classify that as ancillaries. When a node rotates in the network and it starts syncing, it doesn't get that information from an archiver. The archiver doesn't matter in that process. It gets its information from surrounding nodes. Let's see. Some other confusion that we've gotten in previous engagements, finality and long-range attacks. So we have instantaneous finality, not probabilistic. So that means, like in Bitcoin, there might be competing chains that, depending on the amount of energy or power behind each chain, will finally determine which chain is the valid one at the end of the day. We don't have that. We have instantaneous finality, not probabilistic. So we're not vulnerable to those same types of long-range attacks. And as such, we don't need the weak subjectivity checkpoints that some other networks have. The last thing I would like to touch on more generally and philosophically before I get into the code is the role of randomness in our network. So going back to this screenshot, you can imagine like each one of these nodes being the home node of its own shard. And then the shards definitely will have more than one node. We're targeting 128 nodes minimum when we launch per shard. But for this simple demonstration, let's just imagine that, let's say this, for example, is the home node of a shard, and then the shard extends to one node on either side of it. So this will be one shard for a transaction, and then this will be a different shard for another set of transactions, and so forth. When a node rotates in, the nodes in the standby list are randomly selected, uniform randomness selected, and then they are rotated in to a random position, to a random shard in the active network, uniformly distributed again. One thing that we would like the white hats to look out for is any way to game this randomness. If you can influence the system such that you can guarantee that your shard gets rotated in next, or you can guarantee that when your node gets rotated in, it gets put into a specific shard or in a specific place, that is hugely detrimental to our security posture, because that would allow an attacker with a smaller amount of nodes to take over a single shard, and then they would have full reign of all the transactions that go through that shard. They would not be able to touch really transactions in other shards, but they could heavily damage transactions in that specific shard that they take over. So this randomness is key to our security because we want to spread the nodes randomly across the network to make it really difficult for an attacker to target a specific node. Let's see what else. Oh yeah, and this is something we were talking about internally. So how would a white hat prove that they've been able to manipulate the random number generators. Honestly, I don't have a good answer for that. I'll leave it up to the white hats to show that they've been able to manipulate it. It's really easy to show in a proof of concept that like I'm able to guarantee that my node gets in the next cycle or my node gets into the shard. But if you're able to like say, I'm able to increase the chance that my node gets in by 60%, that's a little more difficult to prove, but we'll work with you. We'll try hard to make sure that your proof of concept works. We'll run the simulations ourselves as well and try to get you that payout if it's legitimate. But that's difficult, and there's probably, if you can prove that sort of randomness is broken, there's probably some big bounties heading your way. Let's see what else. So that's kind of some high-level architecture and philosophical bits. Shardeum, Tim, do you have anything you might want to add to that before I open specific pieces of code?
I can just kind of describe, just want to make a note that there are two protocols which we're using in our system. It's like a internal P2P protocol. This is used when nodes are talking between each other, some kind of internal communications between nodes, right? And there is an external protocol. Usually it's a HTTP API on the validator side. Yeah, so it's just pay attention that there are kind of two different protocols going across the system. Yeah.
That's a good point. One of them is more to manage the network itself, so all the nodes are paying attention to the load, whether the network needs to increase in size or decrease in size, and which nodes get rotated in. That's one protocol, and then the second protocol is like the user transactions, for example. So
yeah, correct.
Cool. All right, so let's look at some specific pieces of code here. I see one point on this walkthrough agenda is like good documentation. I'm going to go ahead and post this in the chat. This is our public-facing documentation. It's about as good as you're going to get. I'll be the first to admit it's, probably not the best example of public-facing documentation in the whole world, but we try our best. And if anything's confusing there, please let us know. So let's see. Okay. So let's talk about Score. So there's three repos in the scope, but I want to point out to two of them. The first one is Core. I'll go ahead and post a link in the chat if you need it. So this is the core protocol. Some specific things I would want to point to. These are pieces of code that are complex and critical. I don't want to influence like what type of vulnerabilities you might find there. You might find all kinds of stuff, but this is the stuff where, in my personal opinion, I think that there's good vulns here. So the first, if we go into source in the P2P, this governs the P2P protocol of Shardeum. So there's things like, this governs like how a validator might join the network, how a validator might leave the network, whether it's rotated out or whether it apoptizes, which is this piece of code right here. That's like basically the node taking itself out of the network. Cycle scaling is in here too, the cycle chain, and the cycle chain is like, so each time the network rotates nodes in or out or increases or it shrinks, every 60 seconds, the new state of the network gets added to the cycle chain, and then this is the blockchain of the Shardeum network, is this cycle chain. So the cycle chain, cycle creator, cycle parser, these things are very, very critical to how the network works. Let's see. Lost nodes, for example, is if a node is malfunctioning or malicious, it's not responding, it's not processing transactions correctly, the network will try to see if it's still up and working. And if it's not, it'll mark that node as lost, and then it'll get rotated out in the next cycle. So some funny business could be done there. Actually, funny business can be done all over this code base. It's huge. There's probably a lot of bugs everywhere, but I believe P2P is a place to focus your efforts. Let's see. Next, I want to talk about State Manager. So there's consensus code in here. The global accounts governs like global properties of the network. So if you can mess up mess stuff up in there, that'd probably be a critical vuln. Let's see what else. So consensus partitioning, it's a state manager. Yeah, so if you can mess stuff up in this code while the network is running, you can basically have control of the network. And then lastly, I wanted to look at source network. So an important aspect here is debug middleware. So the nodes have debug endpoints that we use during testing. And these debug endpoints allow developers to get in there and inspect each node to see, try to track down errors and bugs. We don't want those endpoints to be freely available on mainnet. So if you are able to get past our debug middleware and work with these debug endpoints, as someone in this competition already has a confirmed vulnerability for, then you'll get some payouts there too, and you'll be able to wreak havoc on the network. If you're able to turn debug mode on a node remotely, then there's a lot of cash in there for you too. So those are the main, in my opinion, the main big money bug sources for Shardeum or for Shardis. Tim, anything to add there?
I can just on a high level describe what kind of what processes are involved in the network, so people will understand. So we have here two parts of the our kind of blockchain contains two parts. First part is related to it's called cycle chain, which is related to the node structure. So this is a true blockchain where we have kind of handle integrity of our network structure. So what is in our network, what nodes, what archivers, what we have is saved in this blockchain called cycle chain, right? So when new node is trying to connect to the network, it goes to the standby mode. So first it needs to stake some coins. And then after staking the coins, it will get the certificate. This certificate can be used during the join process. When the node join the network, it goes to the standby state. In this standby state, node will be staying for some time until it will be selected by the network using some kind of I will call it reproducible randomness. So all the nodes will reproduce the same selection algorithm, which will select the same nodes from the set of standby nodes. After that, node goes to the syncing state. I think it's a selected state that we added a more detailed state here, but on a high level, it will be selected using this reproducible randomness. Then it will go to the sync state. So sync state means that node needs to sync data from other nodes in a shard, right? The shard depends on a node ID, which is assigned also randomly based on a public key and cycle chain marker, I think. And this node ID defines where on a node ring. So if we can kind of imagine that all our nodes are ordered by the node ID and placed on some kind of node ring, which is splitted by the shards, right? So, and based on where this node was placed after the join process, after the selected process, it will define which other neighbor nodes it needs to go to request the shard data during the syncing process. When the syncing process is finished, then this node report to others that it's active, right? Active node means that it can start processing transactions. So I'm talking about the cycle chain kind of process at the current moment. So then all the nodes sorted during using the join time, right? And the network periodically removed nodes based on the join time, doing this kind of recycling process, right? So after that, active node will be removed, and then it can go again, join the network with existing certificate, be standby, wait until it will be selected, syncing, active, processing transactions, removed, and it goes like in a cycle, right? So this is all the processes which are related to the cycle chain. There are also auto-scaling processes when the network thinks, depends on some metrics that it's not enough processing power and we need more nodes. It will kind of increase the speed of adding new nodes from the standby list, standby set, right? This is another process. It can go like scale up, scale down. Yes, so this is related to the cycle chain. Then we have another part of the system which is relates to the transaction processing, right? So it's kind of isolated from the cycle chain, but the nodes in our network are actually saving this transaction state. Validators only save the last state, so it's kind of snapshot of the last account state, but the history is saved in archiver, right? If you want to see the history, you go to the archiver. If you want the last state, you go to the validator. Yeah, so transaction processing is done in a way like MetaMask using RPC. RPC is using one of the validator in a network, or it can be a service validator for the RPC. It's like a different role for the validator in which validator can work. So the idea is transaction is injected to any validator in a network, and then validator determines where is the home node. So then we have a notion of transaction group. Transaction group is the set of nodes which are involved in providing any data to the transaction. So what I mean,
Hop in real. So a transaction group would be for transactions that involve multiple shards. You could think of it that way. The transaction group is every shard that's part of that. So if one account is on one shard and it's sending money to another account on another shard, both those shards are involved in the transaction, requires cross-shard communication. That would be the transaction group.
Yeah, so and then we have a notion of execution group. So at the current moment, execution group is based on a target address of the coin transfer. So execution group is a shard which is using to run execute transaction. So transaction group can be bigger than the execution group because a transaction can have multiple accounts involved, not only the target account. On our current stage, it's only coin transfers, so we have only 2 accounts, right? So execution group, when transaction is submitted to the nodes in the execution group, they wait for the data from the other shards with accounts involved. Let's say it's a source account, right? So nodes from the source shard will send data to the nodes on the target shard, which is execution group. So when the nodes in the execution group will get all the data needed, they will kind of pre-apply transaction, get local receipt, and see like if transaction is executed correctly. Then there is a consensus process which involves kind of voting, kind of, I would say, decentralized decision making, that the transaction result should be this one, and the nodes should agree on a transaction result. If the nodes agree on a transaction result, transaction will be considered succeeded, and nodes on execution group will distribute result of the transaction to the other shards involved in this transaction to the source, let's say to the source shard, with the account update. So if it was coin transfer, the nodes in the source shard will get decreased account state, right, with the receipt and everything. So that's how this works on a very high level, and kind of what processes are involved during this execution. That's it from my side.
Okay, thanks, Tim. All right, so we'll move on to Shardeum. Some important pieces of code in this is my personal opinion. I want to make clear that there are vulnerabilities everywhere in the code that your expertise will lead you. Like if you're not super well versed in P2P protocols, don't worry about it. Look anywhere else. It's a large code base and we did our best, but vulnerabilities are everywhere, and we're not spending my money, we're spending my boss's money. So I don't care. I'm here to give out money. Okay, so let's see. Shardeum, in my opinion, let's see if we go into source.
I have an idea. Maybe we can focus on most complex functionality in your view. As far as I understand, the most important, in your opinion, is the sharding mechanisms and how nodes are interacting with each other. Maybe something else that you think that particular to you that was most interesting or problematic.
Yeah, that makes sense to me. Yeah, definitely. So it's in most of that is in Chartis core repo. Most of that. So if we go up a level to Shardeum, there's complex code in here too. If you're looking for big bounties, I would kind of focus on Chartis core, but there's bounties to be had everywhere. So yeah, I guess we can just go to questions then. If stepping through the code like isn't adding a ton of value. Yeah, so does anybody have any questions?
At the moment, we don't have questions from our viewers in the chat. Also, I wanted to ask if you received something from your previous audits that you haven't expected to see. Something that challenged the security assumptions or threat modeling that was built inside your team, but it was not the same that you have seen in the audit report.
Sure. So you go ahead, Tim.
Let's go high-level overview on a known bugs. Kind of, it will kind of provide some current state of the issues. What do you think?
Sure. Let me answer Gleb's question first, because there's some insight I want to give there. So we didn't learn a ton about from previous audits about our assumptions or our threat modeling. What we did learn is that a lot of auditors will come in with their previous experience, and Shardeum is just different enough that their previous experience will lead them in wrong directions. The example I gave before is the role of the archive server, and then let's see what else. Yeah, our sharding mechanism is different than normal. So they spend a lot of time dissecting the RPC server, which is common to other networks, and then treating the archive server as though it were key to the consensus mechanism and key to spreading data around the network, and it's not. So I would draw on your previous Web3 experience, but make sure you verify that that's how the Shardeum network works before you run with those assumptions. If I was a white hat, that's what I would do. So Tim, yeah, do you want to go through some known vulnerabilities? Do you have any on top of that in mind that you want to discuss?
Can you open the list and let's? I can go one by one. Maybe there will be questions.
Sure. One moment. Where is that list? I know I sent it to you. Okay.
Did you find?
I found it, yeah. So we do have a list of known vulnerabilities here. I'll post this in the chat as well. I don't know that I want to go one by one because there's quite a bit. But are there any that you want to highlight, Tim?
Let's go down, man in the middle. It's a very simple thing that we're using HTTP, not HTTPS. It's kind of arguable and questionable kind of about the impact. So we just left it here because we didn't do too much investigation here at the current moment. So let's go to the exploitation network node style reporting the false mark nodes as lost. So at the current moment, we didn't find the kind of stable solution during the cycle chain. When we have a cycle chain blockchain, right? When the nodes adding and removing from the network, there is a kind of a way to report that the node is lost. This is happening when some node is like out of service for whatever reason, right? And the network should not spend time kind of connecting, sending data to this network. And there is a mechanism for other nodes to report that the node is lost, and there is a mechanism to validate that this lost report is correct, right? And what we was thinking that there is a way to create like a parasite node which can hide itself as a valid node, but will actually not do anything for the network. And we kind of designing at the current moment, implementing the way to implement this loss check in a way so parasite node will not be able to understand that this check is for the loss check and not any normal request from other normal nodes. So parasite node should not be able to identify and distinguish the loss check and the normal connection and normal request from other node. This is the ticket is all about. Yeah. So
that brings up another point with that. So that speaking a little bit about the one above it, the man in the middle, in HTTP versus HTTPS, there's very few things on the Shardeum network that are actually secret. So the lack of HTTPS communication between the nodes should not be a problem. If you're able to prove that there is a problem, that's fine. But the transactions themselves, there's nothing private. The only private is the keys on this network by design. So sorry, go ahead, Tim.
Yep. So please go potential danger of service of yeah. So this is the thing that there is a limit of the when we have a validator network, the validator network is only contains the snapshot of the data and they process transactions, right? Our archiver is the source of history of the transactions. So we need a way to transfer this operational knowledge about the transactions which are processed to the archiver, which is our storage database. So this is done by on archiver sites, they connected to the random selected validators and kind of listening for all the transactions which validators are pushing to the archivers. But to kind of use load on a validator side, we limit the number of archivers which can be connected to the validator, right? And this bug describes a way so they can be malicious archiver or archivers connected to the network, like a joint network as an archiver, and reuse all the possible connections on validators across the network. So any valid archiver will not be able to connect to the validator and get the new transactions, right? So this is ticket about this kind of stuff. So that's it.
Okay. On that note, if you find a vulnerability between the validator and the archiver, they're spread out over separate boosts. Feel free to submit it to either one of the boosts, and if we feel it's incorrect, we might just ask you to submit it to the other boost. But those are completely on the table. Don't feel bad. Don't be confused. Don't worry about which one to submit it to. Just submit it to either one of them.
Yeah, so deprecated packages and packages with vulnerabilities. This is kind of general issue for other projects, because some of the packages are outdated and very deep in a dependency tree. So you can still see when you will build the project that there are some packages can be outdated. Yeah, we did as much as we can in terms of removing dependencies, vulnerabilities, but still there can be some. So insecure admission of nodes in debug mode in production blockchain network. This is just the way that you cannot kind of reject the nodes in a debug mode, right? That's the thing. That's
yeah. So if you want to join your personal node to the network in debug mode, you can do it. The network's not going to complain. We would like it to reject a debug node, but currently it does not.
Because it's a permissionless network, so you can do whatever you want. Right?
Yeah. A little bit on that note. So the scope in general is the configuration that's in the dev branch in the various repos. You can change your own node however you want, and the attack will still be in scope as long as it's an attack against a node that's running the configuration that's in the dev branch. The only caveat to that is the minimum node size of the network. So you can change the configuration to have a bigger or smaller network depending on whatever fits your hardware as you're testing. However you need to do that. But everything else is generally off limits, unless it's extremely extenuating circumstances. Yeah, but we'll go from there. So we have about 20 minutes left. I want to leave plenty of time for questions. So if we could just get the highlights, Tim. Yeah, go ahead.
No, maybe if you have already questions, let's ask the questions. If we don't have questions, I can continue with the bugs. So,
sounds good.
Yeah, for the moment, we still don't have questions. We did have about POC, and yeah, just had something.
Okay. Usually what will happen in cases where there is a correct duplicate report, but the POC is written badly or incorrect. So
Maybe I can help with this one. I think this is more about Immunefi rules here. So just to read, what will happen in cases where there is a correct duplicate report but the POC is written badly or incorrect? So if the POC is written badly or incorrect, the report will be likely just closed as not valid. Like if the POC is not working, well, the report is not valid. But if it's like a duplicate, it will still receive a reward, but at a reduced rate rather than the chief finder. So likely reports that are not having a good POC or just badly written will not be considered as valid. That's the short answer.
Yeah, and we make use of those POCs because when we go to fix the vulnerability, we need the POC to be able to test our fix to make sure that it's properly fixed.
Yeah, and some of the kind of reports can be arguable. So if you want this to be kind of accepted, we need a POC which will show us that this is the impact and that we will get on our test network if we will run it.
The better, more robust your POC, the more likely it is you're going to get paid. So, okay, shall we continue, Tim?
Yeah, so the lost archiver down, lost archiver up, it's the same idea as for the lost validator node. So the same process we have to mark archiver as down, so it will be removed from the cycle chain and no communication will be done for this archiver. Yeah, so same can be, I would say, injected by malicious actors and depersonalized. So this is a known bug, and we are working on fixing it. Cross-shard. This is from Arcadia. Remember, Mehdi?
Yes. Okay, and I think this is related to contracts. So this, even though it's known, it's not in scope for these boosts. So I think we can skip it.
So reward claim processal, reward time manipulation. Yes, so this I want to add this thing. So it just besides the normal Ethereum transactions, we have in our network the internal transactions, which are used for the different kind of goals. One of the goal is to reward the network for the result, for the time it spent during being active in our network and processing transactions. So we found one issue that the internal transactions related to the reward claim can be manipulated by the external party. And we just disclosed this as a known bug and working on a fix for this. Defect and reward claim mechanism. Yeah, so this is kind of a bug not related to kind of security, but more like a software bug. Maybe. Yeah, so the idea is if the reward claim came, so our network is living, I would say, during the cycles. Cycle is 1 minute duration, and every cycle, the structure of the network can be changing. So some nodes are adding, some nodes are removed, and the cycle chain is kind of finalized for each minute. So any finalized cycle chain will be valid for the next minute, for the next cycle. And this bug describes that if the reward claim came later than the 5 cycles from the time when the node was removed from the network, the node will not be able to claim the reward because there is the way how it's implemented. It's only looking back to the 5 last minutes from the moment when the reward claim transaction was injected or accepted by the network.
Yeah, this brings up a point too, that the reward mechanism code is probably another good place to find high-paying bounties.
I would actually emphasize the area where we can lack of kind of proper maybe implementation is penalties.
Mm.
So yeah.
Our slashing and penalty code is a little thin at the moment. That's an active project ongoing. So I don't know what else to say to that except expect that code to be added. Fingers crossed before the end of the bounty. I mean, it needs to be. But so anything related to like a slashing or penalty not being implemented is probably out of scope. But there are a few slashing and penalties in there that are in scope.
Yeah, I would like to pay attention on this because this is very important for the proof of stake network. So I think, yeah. Good.
And if you're unfamiliar, slashing and penalties are like if your node is misbehaving on the network, 2 definitions of misbehaving. One is it's too slow or its network connection is poor and it's just not keeping up with its job of processing the transactions. The other category is it's being malicious, double signing a yes and a no vote, for example, or whatever malicious stuff a node might get up to. The network can penalize that node and delete some of its stake. There could be bugs in that, so we would appreciate if the white hats spent some time looking at our slashing and penalty code.
So the next bug is pretty interesting. Vulnerability in cycle certificate.
Is this still valid with POCO?
Yes.
Yes. Okay.
Yes, because POCO is transaction related. This is related to consistency of the cycle record. So the idea here is that we are doing. There is a winning process when the nodes decide what should be the network structure for the next cycle or for the next minute in our case. There is a process to select the winner from the list of the proposed network structures, right? And this winning process is based on an ordering of the cycle marker, which is the hash. And the idea was that is that using some GPU farm, you can kind of, by adding some extra payload to network structure, which is not important, some kind of wasted payload, you can change the hash, and by kind of generating this a lot of amount of hashes, you can kind of select the hash which will win this winning process, right? And malicious actor can try to kind of generate these hashes and try to select the one which will win the winning process. Why it's important? Because cycle record defines what nodes are in a network, where they are, what are their archivers in a network, and based on this cycle record data, nodes verify internal communication between each other. So if you can kind of change the cycle record in a way you want, this can be very impactful bug for the kind of security bug for the system, correct?
I agree. Yeah. So insufficient input validation for contract call. That's contracts out of scope. Let's see. Missing validation of cycle data from active. I'll let you lead the way, Tim. Go ahead.
Yeah, so this is the same idea that the way how we decide to solve the previous issue with the GPU hashing is that we need to record all transactions on a cycle chain, like node add, node deleted, distributed across network, so all nodes will know what are the valid set of transactions during the last cycle, and the nodes will then can verify that the proposed cycle record for the next, so proposed network structure for the next cycle is valid based on the transaction which they received from other networks. This is the way, kind of the solution for the kind of this for GPU bug. Yeah. So lack of sender verification and broadcast state handler. I think it's so our P2P protocol has two versions. One is non-binary and the second one is binary. I think this is relates to the non-binary handler. So when transaction is executed, before transaction can be executed on the nodes in the execution group, it needs the data like account states which are involved in this transaction. The node in execution group receives account states for the accounts involved in the transaction using this broadcast state message, which is sent by the source nodes which store the source accounts to the execution group nodes. And the handler of this broadcast state has some issues, security issues, to validate that the sender is correct one. Without this validation, attacker can send invalid state for the source account, and transaction will be executed based on an invalid state of the source account. So for example, instead of source account balance 100 SHM, can be sent like the source account is a billion SHM, and transaction will be running based on wrong initial account state. Yeah, so this is kind of defines this.
Tim, we were just talking about that, so that's already a published issue. So I think we're okay, right? Let's see. I believe this insecure determination of transaction type is fixed. Adequate challenge. I believe that's out of scope.
That's actually told, I think.
I'm sorry?
I think we already talked about parasite.
We already covered the parasite nodes. Challenges and confirmations are not in scope. Challenge system. Inefficient and potential DOS vulnerabilities in transaction queue management.
Okay, so this is for the nonce queue. Some internal queues, the nonce queue on a node can be DOSed. So we just declared here. So we're working on a fix for this. non-skew, which can eat all the memory on the validator.
Inadequate controls on debug transactions in production environments. So we have fixes going in for this, but let's see. I believe that's just what it sounds like. And that kind of leads into a question that was part of our agenda of what are different access control roles within the protocol. So one of them is debug transactions that require multi-sig dev keys, multiple dev keys in order to run. So that's one access control. And the other one is active node versus standby node, or even a node that's outside of the standby list. So only active nodes should be allowed to send certain transactions, and nodes expect and will check that certain transactions only come from a node in the active node list. If a node is or the network in general processes transactions or votes from nodes outside of the active list, then that's a problem, and that's probably a bug that can be paid out. That's the unrestricted proxy request handling allows unauthorized internal requests across nodes. So this is related to our lost node code. Our lost node detection code is a little bit of a mess, but in this specific scenario, the way that we check if a node is actually lost, that we verify a node is lost, is node A can send to node B, hey, check this node, the node that we think is lost. And it does that by sending a specific command, a proxy. So basically, the command originates from node A, but gets sent by node B. It appears like it's coming from node B. That's a problem. We don't want nodes to be able to send proxy commands through other nodes and basically cover their tracks if they're doing malicious things. So that's a known issue and something we're working on. And I think that looks like it's it for Shardus Core.
Yep.
The Shardeum boost. So that's all for us. I kind of liked going through the known issues, because in order to explain the issue, we had to explain more about how the system works. So hopefully that was helpful. Timothy, anything else on your side? Let's see, how many developers in the main team wrote Shardeum Core? I'd say about, we have about 30 active developers now.
Feel free to skip this question. Maybe it's like out of scope of the boost, but a lot, yes, a lot of developers work on this.
Yeah, this is probably a more complex project than most of those that pop up on Immunefi. But we're excited to work with Immunefi.
Absolutely. Thank you guys once again. All right, security researchers, those who are present on the call, do you have any questions for Mehdi or Tim while they're here? Also, as a reminder, Shardeum team is staying insanely active in our Discord, so huge kudos to them. So you can always go to one of our channels, Shardeum Core Boost or Shardeum Ancillaries Boost, and tag them there. They have a specific tag, Shardeum team. They will respond to all your questions. In the meantime, while we're all here, any last minute inquiries from you?
Dropping a couple more links in the chat. One is our public Discord. We're not already on there. And
Thank you, Mehdi.
Architecture.
By the way, architecture documents are linked in both boosts, so they're like at the top in the educational resources, so you can also find them there. Okay, I don't see any questions. Also checking our Discord. Yep, Discord is also no questions there.
Some of the previously disclosed
medicine, something for you, yeah.
Already fixed in subcommits. Some of them. Yeah, that's true. I don't really see a question there, but we sent over our list of known issues to Immunefi, and then in between us sending it over and then posting it, we fixed some of it. So it is what it is. And you'll just links to those commits for reference. I can dig those up. I don't have them offhand, but yeah, I can pass them to Timothy. I'll let him know what to do with those.
Just
Mehdi, you can post them in Discord straight away. Sorry, Tim, for cutting you off.
Oh, in Discord, yeah, that's true.
Just make sure that pay attention that the project is based on a last dev branch, and the dev branch is moving we're adding more commits, right? This is like not a standard bug bounty, at least from my experience, when the dev branches, the SHA is fluctuating, so there is no fixed code base. It's like evolving during the bug bounty.
Yeah, which is tough. But if if we're being honest, this code isn't super mature, and we're adding, fixing bugs. We have our incentivized testnet going on, so that might be a side note. Our incentivized testnet, a good way to familiarize yourself with the protocol is to participate in that, and you might get some rewards once that closes down and mainnet launches. Yeah, so we're fixing bugs from multiple angles. The bug bounty is just one angle.
Because this can raise the issue when the bug was submitted, but based on a fix which is already in a dev repo. Just please don't do this because it will be rejected. Correct?
Yeah, if you submit a bug and then it's fixed after your submission date, you will still get paid.
Yes, but before, I mean, if you're trying to trick the system.
Make sure your POC works right before you submit it on the live dev branch. Like, pull down the latest dev, make sure it works, and then submit.
Very good notes, Mehdi. Yep, thank you. Okay, then I think we can let everyone go. Guys, thank you so much for being here. I think this was an amazing, very detailed presentation. It will also be uploaded to our YouTube channel, let's say within the next few days. I don't want to commit to any early date, but within the next few days, it will be on the Immunefi YouTube channel. And yeah, happy bug hunting, everyone. Indeed, good luck, guys. Good luck.
Thanks, everyone. I really appreciate you joining, and thanks, Timothy and the Immunefi team for hosting.
Thank you. Bye.
Yeah,
Bye-bye.
thank you.